So, according to science, which of these is correct? We have one hypothesis, tree of life. Another hypothesis is more of a forest of life. If you want to follow Richard Dawkins and get excited about the evidence he presented, which meets none of the criteria for high confidence, that's what's being taught to our kids. That's what every high school is teaching. And it scares me, really. The high confidence evidence is vastly opposed to the tree of life, is the point. Dr. Rob Stadler. Welcome to the Faith Science Podcast, episode 42. I'm your host, Jerry Swafford, and on this podcast, we explore the integration of science with faith. Today's question is evolution bad science? One of the things I'm going to be doing today is talking to you about a video that I'll have linked in the description below on YouTube, an interview between Dr. James Tour and Dr. Rob Stadler is his last name. He is, let me talk about Dr. James Tour first. He was interviewing Dr. Stadler because of a new book that he's written. I haven't read the book yet, but I wanted to see the interview and see him really give a little bit of a lecture talking about what he wrote about in the book. And we'll talk about the book in a second. But Dr. James Tour has a podcast called the Science and Faith Podcast, which has its two main words are the same main words for this podcast, where we call this podcast Faith Science rather than Science and Faith. And this term that I have coined, faith science, is really, again, it's meant to be a phrase that is describing the science of faith, but also describing the fact that there is science that has faith behind it, and there is science that doesn't. And there's science that you can trust in, and there's science that you shouldn't trust in, or so-called science that you shouldn't trust in. So I think the difference between faith science and science that you shouldn't trust in is going to be fundamental to what we're talking about in today's podcast. So Dr. James Tour has that podcast, the Science and Faith podcast, and he has this foundation called the Jesus and Science Foundation. It's an interesting thing that he has where he gives out his email address and says, if you are an unbeliever and you want to know about the evidence for the resurrection of Jesus Christ, email me and I'll get on a personal call with you and talk to you about it. So that's a really interesting thing that he does. Now, the podcast he had recently is with Dr. Rob Stadler, who is a biomedical engineer and also an author, of course. And he really came on to basically do a lecture on Dr. Tour's podcast. And then Dr. Tour kind of came in with some interjections here and there and talking about some things to clarify some of the things that Dr. Stadler was talking about. So he's a biomedical engineer, has a bunch of patents, and he basically, similar to me, has this engineering background and looks at so much of what's being called science in relation to evolution. And it just kind of irks him. It irritates him. I know that's how it is with me when I see this. And I think part of his mission, I think part of mine, is to get to a point where we eventually get rid of this idea of evolution as being something that's scientific and get back to something that actually would be scientific. So what we're talking about here, if you're wondering, okay, why are we talking about evolution? Why does it even matter? The reason for that is that the fundamental question here is, how did the diversity of life that we experience come to exist? You have humans, and you have cheetahs, and you have tigers, and you have lions, and you have bears, and you have dogs. You have all of these different kinds of animals. And you also have humans. Again, some people would call humans animals, but again, as a believer, I wouldn't use that term. But all of these living things, how did they come to exist? There are really only two hypotheses here. And so when we're examining which one does science go with, we really have two options. You either have the idea of a tree of life, which is what evolution would say. Now, it's a little bit difficult to see on your screen there potentially, but one of the things that is pointed out, and many of these are images, still images taken from the podcast where he was showing, he had a lot of slides that he was using. I'm going to borrow some of those slides to kind of give you a sense of what he did in his talk. But one of the slides had this image where you have evolution, tree of life, and what you see is the tops, like you could think of it as the top branches of a tree that result in the diversity that I just mentioned: plants and mushrooms and dogs and chimpanzees and humans. And what you observe is that there are no direct observations of anything really below several different kinds of species, or several different kinds of life forms, let's say. So what's interesting is evolution would claim that there is this huge tree of life and all of those different organisms that currently exist are all derived from a single ancestor. So, Why Evolution is True, written by Dr. Jerry Coyne, that is something that he would claim. There's a single ancestor. All of us, not just humans, but all living things can trace their ancestry back to a single ancestor. And so there are no direct observations of this, of course. There's only different kinds of things that have been alive and that we see in the fossil record. But faintly, you can see this idea of those top branches of the tree coming down to some common trunk or some common root. The second hypothesis is that there is a forest of life. And this is what the Bible would claim, that there were different kinds of life forms created at the beginning. Genesis chapter 1, verse 24, and God said, "Let the land produce living creatures according to their kinds, the livestock, the creatures that move along the ground, and the wild animals, each according to its kind." And it was so. So the idea here would be that there are different kinds that God created in the beginning, and from that, there are small variations that result in the diversity of life that we currently have. But there was some diversity at the very beginning, but there is even more diversity now, apparently, from what we see. We, again, don't know how many different kinds there were at the beginning. But this is a hypothesis that says there was creation, and then from the creation of different kinds, you have the diversity that we currently see. So the question we're asking is, which one does the scientific evidence support? Now, there are two major issues. Clearly, those who claim to follow science, or many people that would claim to be scientists, say that evolution is clearly the hypothesis to go with. And in fact, they don't really even dignify the alternative. So that we've said, okay, it could be a tree of life, but it could also be a forest of life. And even if we say it's a tree of life, as we've just pointed out, there is no direct observation of the bottom part of that tree that they claim to have happened. So that is generally not claimed. That's generally not said. So the first issue with the so called science of evolution is that the alternative hypothesis and its evidence are never presented. You never get the creation view. In fact, if you try to give the creation view, there are many people that come out of the woodwork and say, "You're not doing science. You're not. You can't. You're bringing God into the schools and all of this kind of thing," and they get very angry about it. But what's interesting is whether or not you put God into it or not, it is a hypothesis. And it is a hypothesis that most people believed throughout most of human history. And it's only been recently that there have been these proponents of, let's not even talk about that hypothesis. My thing is, hey, put all of the information out there, particularly if you have a hypothesis that is so unscientific like evolution is, but that gives you a clue as to why I believe they are so vehemently opposed to showing any other hypothesis, because it will become clear how much of a better hypothesis that is, the creation view, the view of a forest of life, is compared to the so-called macroevolutionary view. So the first thing is, it's supposedly science, but we're not going to look at all the hypotheses. We're only going to look at one. So you're going to look at one option. That's what you see in the biology books. There are no other options that are given, and if you even try to say another option, people get angry. These people that are proponents of this. That's not how science works. Science is all about true science. Now, again, I'm saying that this is really fake science. It's not something that I would call faith science. It would be fake science. And so fake science says we'll have this biased view and we don't want to hear any other view besides that one. And then you're going to call that science. Now, the second issue here is that low confidence evidence is given and preferred over high confidence evidence. Now, you might be saying, okay, Jerry, what do you mean by low confidence versus high confidence evidence? And this is what he gets into in his book, Dr. Stadler. The book that he is promoting right now is called The Scientific Approach to Evolution. what they didn't teach you in biology. Now, I took AP biology in high school, and I believe I got a 5 on the test. It was either a 4 or 5. I think it was a 5 though. So I know what they teach in these biology classes. So this is not something where sometimes people will come in the comments, or they'll email me and they'll say, no, you don't really understand evolution. It's like, no, I understand evolution. I in high school was taking it for college credit, and so I understand what they were teaching. The issue is it's not science, and we'll talk about why that is, and we'll talk about why we continue to try to harp on this and really try to point this out to people, because once you see it, it's very difficult to unsee it. And then you start getting irritated when you see the number of people that are out here using really bad science to justify this stuff, and then saying, this is why I deconstructed from my faith. Those of you who say that, sometimes I have people in the comments that say, I was a believer, but when I saw the evidence for evolution, that just turned me away from faith. And I believe that's the point of this theory, right? Like, that's the point of it. That's why they are so vehemently opposed to you seeing the truth about creation, or seeing even the evidence of creation, is because they want you to deconstruct from your faith. So the second book here is actually an earlier book, The Stairway to Life, where an Origin of Life reality check. And I think it's somewhat related, but again, this idea of the scientific approach to evolution is really what Dr. Stadler was really focused on in the podcast. So he gives 6 criteria of high confidence evidence in science. And this is really important, because what you're going to do is, when you see these 6 criteria, you go, okay, that makes sense. If I have evidence that has these 6 criteria, then we can trust more in the conclusions that will come from these 6 criteria. The first one is repeatability. So if I have an experiment of some kind, and I give you the results of my experiment, but then nobody can repeat it, nobody can do the same experiment and get the same kind of results, we would say that is not repeatable in the scientific arena. And so if you have something that's not repeatable, that's going to be lower confidence than something that is repeatable. The second one is that you have direct measurements that are made. So not something where you're coming up with indirect conclusions or indirect measurements, but you are directly measuring something. So the example he gave was, if I want to figure out how fast an object falls on Earth or in a certain locale, then I need a way to directly measure that. So I might drop the ball from a certain height, and I directly measure the amount of time it takes from the drop to where it hits the ground. So there need to be directness of measurements. I don't want to hear about indirect things if we're going to call this high confidence evidence. Now, you probably are already getting the sense that when you talk about even these first 2, neither of these are characteristics of any of the evidence that's presented for evolution. And this is the point. Third, that there are prospective or planned studies. So if you have some study that you can do, that you plan ahead, you have a hypothesis, and you then do the study, and the study lines up with the hypothesis, then that is better than what would be called a retrospective study, which would be the idea where you basically look back on things that had happened in the past and try to make conclusions based on that. Well, you'll notice all of the evolutionary, let me not say all, much of the evolutionary studies many of those that are presented are retrospective. They are not prospective. It's not something where you come up with a hypothesis, and then based on that hypothesis, you come to some conclusion. Now, there are some that will claim that that's the case, but we'll talk about the nature of some of these in a few moments. Fourth, this is really important, the avoidance of bias. Now, here's the thing. Everybody has bias. So I don't come to you saying I'm completely unbiased. Obviously, I'm a believer in Jesus Christ. Obviously, I'm a believer in the Bible. So I'm going to have a bias toward conclusions that line up with that. There's no question. But you should at least be avoiding bias. One way to avoid bias is to actually look at all of the evidence. And so this is the problem. When you have people who make claims about the Bible, for instance, who don't read the Bible, well, how can you avoid the bias that you already have against it? So one of the things Dr. Tour talked about in the video is that you often have people that claim that there are all these contradictions in the Bible. And then upon further inspection, you realize that these things that they're claiming are contradictions are easily answered. People have answered them hundreds of years ago, and people are still just just giving some list that they got from somebody instead of actually looking themselves. So look at the evidence for yourself to avoid bias. If you're here watching this video or listening to this as a podcast, and you are an atheist or you're somebody who believes heavily in the macroevolutionary hypothesis, then this is good for you to at least say, I'm not going to be biased. I'm going to at least, or I'm going to have as little bias as possible. I'm going to avoid bias. I'm going to listen to this other viewpoint. But so often what happens is people stop up their ears. They don't want to listen at all. Now, as a believer, I have to hear this evolution stuff all the time. So I literally have to hear that side and then be able to have answers for it. But so many people who are on the evolutionary side, they never really listen to the creation side. In fact, they reject it outright without even looking at the evidence. If you do that, there's no way to avoid bias. So you're clearly biased against anything, for example, that would claim that there's a God. Avoidance of assumptions. This is one of the big ones that we see with evolution, particularly. There are always these assumptions that are made. And what happens is people will give conclusions, which is the sixth one, that you should make reasonable claims. Let me put them together. Often you have claims that are completely unreasonable based on the evidence. But the only reason why they seem reasonable to those who believe them is that they have these assumptions that they are making that they cannot prove. And so you start off with these presumptions and assumptions, and that's what gets you to your conclusion. And what often happens is, I want to know, hey, what are the assumptions that you're making here? And what you find is there are all kinds of assumptions that are made that you have no evidence for. And then you end up making claims that really are unreasonable. You shouldn't be making them, but people make them anyway. So if we think about what constitutes high confidence science versus low confidence science, we just mentioned what high confidence science might mean, like how fast an object falls. So we would come up with experiments and do them in a way that would be repeatable. We would want to directly observe the different aspects of that experiment so that we could come up with good conclusions. We would make it a prospective study, meaning that we would plan ahead how we were going to determine this. We're going to be careful to avoid bias. We're going to be avoiding assumptions, and we're going to be making reasonable claims rather than claims that are unreasonable. Sometimes you have claims that are completely unreasonable made by people that call themselves scientists. And one of the best examples of this is during the period of COVID. During 2020, 2021, there were all these claims being made that were completely unreasonable. I would see, and it was just really especially obvious in the medical field. At that time, I was obviously still in graduate school, and I would deliver pizza to make ends meet. And I would deliver to these places. I would deliver to restaurants. And let me talk about restaurants, then I'll get to the medical people first, and then we'll get back to this. Let's do story time for a second. I would deliver to restaurants, and they would literally make you wear a mask when you walked into the restaurant. And as soon as you sat down, you could take it off. And it was always funny to me because I was sitting here thinking, okay, so is it that the air where you're standing up is polluted, but once you sit down in a booth, it's not polluted? Because this is literally what people were doing. And they would get so angry with you if you were standing with no mask on. But as soon as people sat down, it was like no problem. And the people are sitting in the restaurant for an hour and a half with no mask on. But as long as you're sitting in the booth, it's fine. And so people weren't taking a bite and then putting the mask back on. No mask the entire time. But as soon as you stand up and get ready to walk out of the restaurant, you better put your mask back on. This doesn't make sense. And the idea that there's a difference between sitting down and standing up is an unreasonable idea. One of the things that was most unreasonable about the entire thing is that you had people saying, we can stop COVID. Like I saw this on many different. I would deliver to a lot of these assisted living centers and hospitals, and you would see language from medical people saying, basically, wear your mask so we can stop COVID. And it was this really weird thing where you're talking about stopping a virus. You can't stop a virus. That's not how it works. But people were saying it, and if you just try to think about it and say, well, that's an unreasonable claim, people would get angry. And you could be walking outside with no mask on and people get angry at you. You could be sitting by yourself in a large room. I did this at the university. I was sitting by myself in a large area, kind of out in a hallway, and someone walked by and just gave me a mean look because I was by myself. There's nobody, there's very few people in the building. So someone walking by me looked over, saw I didn't have a mask on, sitting by myself, and they gave me an evil look because I didn't have a mask on. And it was just these weird things where people were making these assumptions. They were completely biased and they had these unreasonable claims that they were making. What I want to say to you is not only did that unscientific mindset infiltrate the medical profession during that time, but it has already infiltrated the discipline of biology. So, for example, Doctor, um, I keep forgetting his name. How I keep wanting to say Stanford, but it's Stadler. Um, Dr. Stadler had this quote that he took from his son's AP biology book. And the quote is this: for example, organisms as dissimilar as humans and bacteria share genes inherited from a very distant common ancestor. That is an that's beyond an overstated claim. I'm going to suggest I'm not just going to suggest to you that is not what happened. But those who believe in evolution will say it happened. And the issue is, even if you do believe in evolution, you ought to be for, okay, let's show the real science for it. And if we show the real science, then people like Jerry aren't going to be able to say anything against it. But if you have people making these overstated claims like this, to say that humans and bacteria share genes that were inherited from a very distant common ancestor, you are assuming the very thing that you need to actually show scientifically, a thing that you cannot show scientifically. So when you do that kind of thing, this is why someone like Dr. Stadler, someone like me, Dr. Swafford, someone like Dr. Tour, we're all saying, whoa, 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 whoa. That's low confidence science, what you're doing there. So let's ask the question: do humans and bacteria share genes from a common ancestor? Notice that there is bias in the very question that you're asking. Why not instead say, hey, what is the origin of humans and the origin of bacteria? That would be a balanced question that doesn't assume the answer inside it, right? Saying how fast does an object fall doesn't give you anything about is it fast, is it slow, or anything like that. But to ask the question, do humans and bacteria share genes from a common ancestor, you're already biased. You are already making assumptions. Because if someone says yes or no, first of all, you can't possibly prove it scientifically because there are no direct observations that you can make. But secondly, again, it's baked into the question, this idea, well, of course they do. So, can you repeat anything that could answer that question? No. Can you witness any kind of observation or measure anything or observe anything to give an answer to this question? No. What can you do any kind of prospective study to answer this question? No, it's only retrospective. All you can do is look at things that have happened in the past and look at evidence indirectly. It's clearly biased, the question. There are so many assumptions that are baked into that question and that are required to answer the question. And again, as we just mentioned, the idea that you can just say that bacteria and humans had a common ancestor is completely overstated. You cannot possibly prove such a thing, but you're saying it as if it's scientific. And this is why I get pushback from people, because they read these kinds of statements in the science book, in the biology book, and instead of saying, well, is that science or not, they just assume it's science, but it isn't. And the kinds of science that these biologists or these people that write these biology books do is not anything that resembles the kind of science that you have to do as an engineer, right? If you're creating a medical device, if you're building a bridge, if you are building a robot, it needs to work. And if it doesn't work, people turn and look at you and say, hey, what's going on here? So you have to use real science there. These biologists that come up with these kinds of ideas, they don't have to be checked on it. They can make these claims, and if they're wrong, it doesn't really bear itself out. They can just keep saying it, and they are going off of being experts. By the way, expert opinion is low confidence science. There's nothing that looks like those other six things, but this is what people often do. And one of the biggest pushbacks that I get is, Well, all these experts say it. That's low confidence science. Show me some high confidence science, and then we have something to talk about. But when you look closely, it's all low confidence science in favor of evolution. So, what evidence do we have in support of evolution? And again, keep those 6 criteria in mind. When you have someone saying organisms as dissimilar as humans and bacteria share genes inherited from a very distant common ancestor, then the question we need to ask is, okay, what's the evidence that you have of that? And we just mentioned that those 6 criteria all are broken by that statement. But the evidence that is generally told, and it was interesting, Dr. Stadler gave a quick video clip from Richard Dawkins talking about this. And Richard Dawkins said the fossil record, geographic distribution, essentially of life forms all around the world, vestigial organs. What he means by vestigial organs is something like the appendix that at one time we thought was just completely an organ that's not useful, and that was something that maybe a previous ancestor had, and now we don't use it anymore. We now know that many of these things that are called vestigial organs actually do have a use. We just didn't know what they were at the time. And this is the problem with evolution, that idea that there would be organs that you don't use has borne itself out to be false. But guess what? They still claim. They still make these claims that we have these parts. Well, you have a tailbone, what we call a tailbone in the human body. Well, you have a tailbone because of a previous ancestor had a tail, and then eventually the tail dropped off, and so you have a tailbone. Instead of saying, well, do we don't really know that. We're making assumptions about that. The fourth one is a comparison of life forms. And so and Richard Dawkins in that clip said the most compelling evidence is this comparison of life forms, and the biologists love this. Now here's what you need to understand. Look at all 4 of those pieces of evidence. This is the best evidence. This is the guy that beats the drum for evolution and claims that there is no God. Of course, he says that that evolution and natural selection, that is the blind watchmaker, is what Dawkins has said. The best evidence, the most compelling evidence for Dawkins, is comparison of life forms. That is low confidence evidence. It's low confidence. You're comparing life forms, and then you're going to make assumptions based on the similarities between the life forms. That's low confidence evidence. If you look at the fossil record, it is retrospective. And by the way, the fossil record doesn't show a tree of life anyway. As we pointed out earlier, if anything, it's going to show those top branches, which just as easily can apply to a forest of life. In fact, that's what we are claiming here. It certainly doesn't show a tree of life. So all of those vestigial organs, what are you doing? You're making assumptions about what that appendix or what that tailbone must have done in the past. You look at similarities between life forms in terms of comparison of life forms to say, hey, that chimp has a nose that reminds me of a human, or has eyes that reminds me of a human. It has a mouth and these kinds of things. And therefore, they must have had a common ancestor. And this is what is being called science, but it's low confidence science. It's I hesitate to even call it low confidence. Some of it is no confidence. What confidence can you put in something like that? So, what is the high confidence evidence for evolution? So, one of the things that Dr. Stadler does in his talk is he says, look, let me give you some examples. Let me give you a couple of examples of high confidence evidence for evolution. So I kind of sat forward. I was like, okay, let me see what he's got. Like, what is the high confidence evidence that he's got? Because I want to hear this. Because this is what I always say in my talks with and in emails and going back and forth in comments. You'll hear people talk about evolution has all this evidence. This is the thing that Dawkins says all the time. Oh, there's just so much evidence, but if I had to narrow it down, it would be this. And everything that he gives is low confidence evidence. So what's the high confidence evidence? Well, there are these experiments. Sometimes they're called the Lenski experiments. Richard Lenski did some experiments with E. coli, where they basically just, because E. coli can rapidly generate itself, you can go through many generations very quickly. Then it gives you a sense of where you can study evolution, where you can come up with hypotheses and actually do prospective studies in the case of E. coli. So this is a bacteria. So in their experiments, they saw that they were able to get the E. coli to develop the ability to eat citrate in the absence of oxygen. Now, it's not that E. coli can't eat citrate, it's just that they're not able to do it in the absence of oxygen, usually. But they were able to develop the ability to do it in the absence of oxygen, and this was viewed as, over something like 33,000 generations, they were able to get it to develop reliably this ability to do this. Now, once they reviewed it, they figured out, well, this wasn't because there was some new information that was developed, that some new information that was generated by the mutations, but instead there were just some mutations that were done that occurred in the existing genetic material, and that is what caused it. In fact, there was a gene that didn't work as well later on, and we see this all the time. We see so many times where there's something that is viewed as a benefit or some kind of advantage to mutation, that on closer examination you find out that there's something else that breaks down. So when you look at someone, the example that's often given is how someone with sickle cell anemia is less likely to get malaria. I believe is the one that they always give. And the issue there is the person has sickle cell anemia. Are we really saying that there was some kind of improvement? Oh, so you are less likely to get malaria because you have sickle cell anemia. And we're supposed to think that that is some kind of beneficial thing that happened, rather than saying, okay, your genes broke in some way and there was some advantage here, but there was also a disadvantage over here because you have sickle cell anemia. This is what we see here with E. coli. It developed this ability to eat citrate, but it also had something else that broke. That so there was always something else that happens as well. But the point is, here it took tens of thousands of generations to get this to happen. This is a very important point. Now, in some other experiments with E. coli, what the scientists did is they intentionally damaged a cell. They basically took one letter of the DNA and they changed it. And they would make one mistake in the DNA. And when they made one mistake in the DNA, by going through evolution, the E. coli was able to repair that damage to the DNA. And they go, oh, okay, there we go. There's evidence of evolution. Now, again, we'll talk about the difference between the evolution we're seeing here and what people are claiming is evolution, because that's the bait and switch that's happening here. They did this with a different, so the first time they changed one letter of the DNA, and the ability that they were seeking to damage was compromised, but it wasn't completely taken away. And then the E. coli repaired itself over many generations, and so it was able to repair the thing that they intentionally damaged. They did this again. They took they changed one of the letters of the DNA, and when they changed one of the letters of the DNA, it completely took away this ability. And what happened was that that the E. coli, via evolution, over time, small changes, it eventually figured out. Again, I'm giving it agency here, but essentially, the E. coli redeveloped the ability that was taken away because of the genetic damage that was intentionally done. But again, we're talking about one single mistake. Here's what the interesting thing was. In the third set of experiments, they did both. So in one case, they changed this one letter over here. And then in the second set of experiments, they changed this one letter over there. And evolution was able to, over thousands of generations, repair the damage and reestablish this ability that it currently didn't have. Now, it's not eating citrate, it was something else, but it redeveloped that ability. What's interesting is that in the third set of experiments, they did two. So they did both of the different ones. And the thought was, okay, we'll do two different mistakes here in the DNA and see what happens. And what happened was the E. coli was not able to repair the two mistakes. You might be saying, well, Jerry, Why is that significant? It's significant because we're talking about literally 99.9% of the DNA was the same as the completely healthy E. coli. They damaged 2 letters. And if there was just 1 letter, evolution was able to eventually repair the 1 letter in 2 different instances. But as soon as they tried 2, they could not. And they did this multiple times, of course. So this gets back to the repeatability part. They were able to repeatedly repair 1. As soon as it went to just 2, they were not able to, through via evolution, get the E. coli to repair itself. And so what it eventually did is it completely didn't even try to have that ability. Now think about that for a second. When you think about how they are saying that everything that has come to exist is doing that via evolution. And we see here that you have 2 small changes and the evolutionary process is unable to fix those things and get it to have this ability. You begin to see what the limits of evolution are. Now, the third thing that I have to include here is that in every one of these experiments, and I've had people bring up experiments like this to me, people who are atheists or evolutionists. And this is the thing I always ask. It's very simple. When these guys did these E. coli experiments, what did they start off with? And the person says, well, bacteria. What did they end with? And in every case, they end with bacteria. In every one of these evolutionary experiments, they end with the thing they started with. You say, well, that thing is different or it has these different attributes and all of this stuff. Yeah, I know it has different attributes. What I'm asking is, did it ever turn into something else? And of course, the answer is no. There is nothing that we directly observe that ever turns into something different. So when you say that a plant may be turned into a bird, may be turned into an elephant, may be turned into a chimp, may be turned into a human, what you're doing is you're inevitably doing what we would call extrapolation. We'll talk about what extrapolation is later. But what you're doing is you're going from these tiny changes that we see in chimps, in E. coli, in plants, in lions, and you're saying those tiny changes that we see, like in the case of this, where it took you 30 something thousand generations to change 1 letter of the DNA to get it repaired. And we're being told that that is how these huge changes have occurred. So these tiny changes, we see that happen. We see small modifications. What we do not see are these huge, widespread, body level changes in organisms, in life forms. So when we look closely at the high confidence evidence for evolution, these repeatable experiments, what we see is it takes you 30 something thousand generations to deal with 2 specific mutations. In the study of the tryptophan synthase, where they are, again, making tryptophan, thousands of generations couldn't repair those 2 specific mutations. There, you could get 1 mutation repaired, but you couldn't get 2 mutations repaired. And so when you see that, this is the high confidence evidence. And really all it shows is what we already know, which is that microevolution, small changes or modifications in existing life forms and in populations, is what we observe. The fundamental question here, so whether you're an atheist or a believer, the fundamental question is, can you extrapolate those small changes to become these large, widespread changes? And all of the scientific evidence points to there are clear limits on how much evolution can change something. So now we have a problem. If you believe everything came from a single ancestor, but we see that evolution is clearly limited, we never see evolution develop something that's different than what it began with. Again, when I say different, I mean a bacteria becomes a frog becomes a sheep becomes a, and you might be saying, well, Jerry, that's just very huge. But no, let's say a frog becoming a snake or some kind of other amphibian, like clearly different. We never see that. It's not observed ever. And so this idea that it must have happened not just once, but everything that has come to exist happened that way, but you never observe it in the real world is not science, folks. That's not science. That's a faith, that's a blind faith because there's nothing to show that. So that brings me to the humans and chimps, right? This is because I work with humanoid robots, this is something that has always I'm saying irked me, but it's irritated me that you'll have people make this claim that chimps turned into humans, and you have this progression from some kind of ancient primate to the human. And there's no evidence of this in the fossil record. There's no evidence of this from all of those different low level or those low confidence pieces of information and evidence. And yet people continue to claim it. This is an interesting quote. This is from about 12 years ago. And the scientist is called, it's from New Scientist magazine. It says this: when biologists began sequencing genomes, they discovered that up to a third of the genes in each species seemed to have no parents or family of any kind. But where did they come from? With no obvious ancestry, it was as if these genes had appeared from nowhere, but that couldn't be true. Everyone assumed that as we learned more, we would discover what had happened to their families, but we haven't. Quite the opposite, in fact. Notice what she says there. With no obvious ancestry, it was as if these genes had appeared from nowhere, but that couldn't be true. Now, what do you mean that couldn't be true? But this gets back to the bias. The idea that it couldn't be true means we all know, is what they would say, we all know that we all came from a common ancestor. But then we're seeing these genes that are what are called orphan genes, meaning you can't trace it back to some other ancestor. But there has to be a common ancestor. But that's an assumption. And so what happens is they said, well, we'll learn more about it by and by, right? We'll come to understand it better by and by. And then what happens is it just creates more and more questions. The more you look at the evidence, the more you see that what they are saying here is not what happened. It's not what we see in the record. So this brings me to something that's also really irritating is when people look at, for example, the picture of the guy on the left, or look at me under this picture of the chimp and say, well, you see the two eyes and you see the nose and you see the mouth, you see the ears. Can't you see the resemblance? And what goes on top of that is that they will then say that, well, most of our DNA is the same as a chimp's DNA. That's just not true. And so this quote here from a paper back in 2006 says that, again, from their results, the human genome contains 1,418 genes, 6.4% of all genes that do not have orthologs in the chimpanzee genome. Okay, let me translate that to you in common language. This group of scientists said that when we looked at the human genome, we found 1,400 plus genes that are in humans that aren't in chimps. In fact, let me just read to you what Jerry Coyne in the book Why Evolution is True. I often quote this book. I quote it in my own book because I always want to get the perspective from someone who truly believes that this is true. This man wrote a book called Why Evolution is True, and in his book, he said more than 6% of genes found in humans simply aren't found in any form in chimpanzees. There are over 1,400 novel genes expressed in humans, but not in chimps. So he expressed it very well, the result of that paper. Now, think about that for a second. You've probably heard somebody say that 98% or 98.5% of the genes of humans and chimps are exactly the same. And that is just not true. And I want to show this in a second, but I want to stay here for a second. We're going to actually look some stuff up online really quick. But I just need you to understand, human DNA is not 98% the same as chimp DNA. I know people say it, but it's just not true. And we just saw that someone nearly over 15 years ago wrote a book, and he's an evolutionist. And he says himself, over 6% aren't found in any form of in chimpanzees. And chances are, this is something that Dr. James Tour talked about in the podcast. Chances are that number is even higher now that we continue to learn more and more. So that's a lot of genes that aren't the same as chimps, but you keep hearing this 98% number. So let me look this up really quick. Let me say human DNA similar to chimp DNA. Now, if you look at the AI overview here, the AI overview says that humans and chimps share a high degree of genetic similarity, with estimates ranging from 95% to 99% of their DNA being identical. Now, here's how I can tell you right off the bat that that's a lie. Because if you think about the differences between even humans, are we really saying that 99% of we're 99% the same as chimps, but two humans are also are not 99% the same? Of course not. Now, notice this. Humans and chimpanzees share a common ancestor that lived approximately 5 to 7 million years ago. Based on what? What's the evidence for something like that? I can assure you, it's all low confidence evidence at best, a bunch of assumptions, and clearly a great deal of bias. Here's the thing. Most of what they're not really telling you is that they're focusing on protein coding sequences of DNA. This is the issue. Now, let's look at let's look at this paper. Divergence between samples of chimpanzee and human DNA sequences is 5%, counting indels. Now, if you notice here that this paper is saying that, 98.5% of our DNA sequence with chimpanzee is probably an error. So this paper is essentially saying, this is back in 2002 even, that this idea that 98.5% of human DNA is the same as chimp DNA is just not true. And so what they do is they go, well, the number is probably closer to 95%. Now, if you look closely at what they're actually saying, they're saying that 5 chimpanzee bacterial artificial chromosome sequences have been compared with the best matching regions of the human genome sequence to assay the amount and kind of DNA divergence. Now, think about what they're saying here. They're not actually comparing the entirety of the chimp genome to the entirety of the human genome. They're taking some samples. So what they do is they take some samples of DNA that, frankly, they expect to be very similar. But there's plenty of DNA that's not like that. And that's what we're talking about here. And so much of what's called junk DNA, they don't really call it that anymore. They used to have, they used to talk about how there was some DNA that they would always call junk, meaning it doesn't do anything. And the more we've studied, we find out, actually, it's not junk DNA. It actually has a purpose. Same thing with these vestigial organs. These organs that don't have any purpose, we find increasingly over time that they do have purpose. Now, here's the thing. The belief in evolution is what caused these concepts like junk DNA. It's what's caused these concepts like vestigial organs, or these organs basically being junk organs or leftovers from a previous ancestor. When we find out that that's not true, why don't we go back and look at the hypothesis that created those false assumptions? No one wants to do that, or these people don't want to do that. Often, these evolutionary conclusions lead to bad science, and people are sitting around calling something junk DNA. They are looking at the differences between humans and chimps and completely ignoring large amounts of the DNA in humans and chimps, and just not ignoring that and not including that in that 98.5% number. So that paper back in 2002 said, well, it's probably closer to 95%. Well, we now know it's much different than that. And that even in that case, they were taking bacterial artificial chromosomes, right? And samples of them, and then comparing that. Well, that's not the same as comparing the entirety of the human genome. But then when you give this to popular science or you give this to the news, they'll just completely they'll completely miss out on the nuances of what's in the paper. So, this idea that human DNA and chimp DNA is 98% the same is just not true. And this is something that really got under Dr. Tour's skin and still does. And I know it does for me as well, because you make that statement and that causes somebody in their college biology class or in a high school biology class to say, oh, well, therefore, humans and chimps must have the same ancestor. And that the closer that our DNA is to each other, that must mean what these scientists are saying. Again, I hesitate to call them scientists because the way they're doing with this really low confidence, heavily biased, and all of these assumptions, the way they're doing with this is just not good science at all. So towards the end of towards the end of his talk, this is what Dr. Stadler said, and this was our quote to begin with the pod today. So according to science, which of these is correct? We have one hypothesis, tree of life. Another hypothesis is more of a forest of life. If you want to follow Richard Dawkins and get excited about the evidence he presented, which meets none of the criteria for high confidence, that's what's being taught to our kids. That's what every high school is teaching. And it scares me, really. The high confidence evidence is vastly opposed to the tree of life, is the point. What he points out here is that you have a hypothesis that has this really low confidence evidence behind it, that when you look at all of the high confidence evidence, it actually points not to the tree of life, but to a forest of life. Now, when you point that out to people, again, it's very difficult to point that out to people because they've been conditioned to be biased against anything other than the acceptable view. That's not science. That's something else. It's not science. It's pseudoscience. It's fake science. So when you look at science, which one's correct? Which one has the highest confidence evidence behind it? Well, you have the tree of life, which essentially assumes that there's a common ancestor. It is biased away from anything other than that concept. And we could talk about why that is. It's because it makes it easier to not believe in a God if you can show that there was no designer. What we see is the very tops of the branches, which is what we observe in a forest of life framework, which goes along with the creation view. So if we're looking at what the high confidence evidence is going with, which one seems more correct according to science, it would be the forest of life, not the tree of life. And we saw that the best of the high confidence evidence still points to the forest of life, not the tree of life. So, one of the things he ended with is talking about this conflation between microevolution and macroevolution. And when I bring this up, often evolutionists get angry or atheists get angry because they say they're the same thing. And this is precisely the point. And if you're an atheist and you wonder why we get angry at this, it is because if you truly don't see the difference, I'm hoping that I can show you the difference right now. Because what you're doing is you're conflating two different things. And it's very difficult because if you can't understand the difference between these, then that's where it makes it so difficult. Because what happens is people will look at the thing that we do have mounds of evidence for, the thing that no one actually disputes, which is what I would call microevolution, small changes in a genome via mutations and natural selection. There's no question. We see it. And this is the thing that Darwin pointed out, and more power to him for pointing it out. The issue that Darwin had is he then extrapolated out to something else. He extrapolated out to many generations that everything has a common ancestor, that how life came to exist, the diversity of life that we see can all be traced back to some kind of macroevolutionary process where instead of small changes in a genome, you have large-scale changes in body plans. There's no evidence for that. And again, I don't want to say there's no, but all of the evidence that you would use to justify that claim is low to no confidence evidence. And we saw it today. And so for those who would say that's not true, please show the high confidence evidence of this. What you'll find is that there isn't any. And biologists will admit as much. But as long as you have something that rather than nothing, they're fine with just giving you a bunch of low confidence evidence. And then let's not talk about the alternative. Let's not talk about this other hypothesis. The problem with talking about the other hypothesis is this. If you show the other hypothesis, it's going to look a whole lot more plausible than their hypothesis. So therefore, we have to put all of our energy into not letting you see that. And if we can do that, and if we can just teach the kids, then they just won't even look at the other hypothesis. Now, again, as believers, we have to constantly be inundated with this really bad hypothesis of evolution. Now, here's the thing. In the past, when the believers were in power, let's say, they didn't allow for the macroevolutionary idea to be taught in schools. And now we who live, 150 years later, have dealt with this tide turning in the opposite direction. And just like the believers in the past said, we don't even want you to talk about that in school, which I think would have been wrong then as well. Talk about it, but show the evidence for each. But the issue is, in those times back in the late 1800s, early 1900s, they pushed against it so much that when evolutionists got the opportunity to then dictate what would be taught in schools, they turned around and did the exact same thing. And so no one said, okay, let's look at both and let's see which one goes along with the scientific evidence. Those who were in power were essentially saying, we're just going to show you one. And what I would urge you to do, if you're someone who is a believer, you need to know a little bit about it. You need to know something about it. You don't need to study it that deeply because there really isn't a whole lot to it. And all of the evidence for it is this low confidence evidence. But you need to know something about it. And if you just stop up your ears and you don't up with is not really knowing why you believe what you believe. And yes, you believe what you believe because the scripture says something that's the opposite of evolution, but it's more than that. You should be able to also look at the world and say the world doesn't work the way these evolutionists say it should work. So Dr. Stadler said towards the end, in all of science, the term extrapolation it throws up red flags in your head. Extrapolation is dangerous in science. Macroevolution is extrapolated evolution, meaning we see these small changes. No one disputes that. What we do not see are the large wholesale changes in body plans that the evolutionist claims. That is something we don't observe. It is extrapolated. You see these tiny changes and you say, well, if you extrapolate that out 100,000 years or 100 million years, you could have bigger changes. That is what Darwin did, and it was wrong. That is what people are doing today, and it is wrong. And so that's what we want to point out here. That's what evolution, true evolution that we see in nature and in the world, are these small changes. But the big changes, the extrapolated evolution, we don't see any evidence for that. You have to make assumptions and you have to be biased against any other interpretation of what you see. So the high confidence scientific evidence does not support evolution. It just doesn't. It doesn't support this idea that these tiny changes can add up to big changes. In fact, what you constantly see is that there are limitations on evolution, that the high confidence scientific experiments always point to limitations in evolution. And you never see E. coli turn into something other than E. coli. You never see rats turn into something other than rats. You never see people turn into something other than people. And so the issue is that the very thing you need to prove, you can't even prove it on a smaller level. You can't even get that E. coli to turn into something other than E. coli bacteria. You can't do it. So if you can't do it on that small level, what makes you think that it happened on the larger level? And what makes you think that you can say that bacteria and humans have a common ancestor? You can't make that claim scientifically. It's a faith claim and a claim that's based on something you cannot observe. So it's blind faith, fake science. So there's this really interesting video, why evolution is a fairy tale for grown-ups. That's one of my favorites that discusses this topic. Non-life doesn't give birth to life. And what we see is in these evolutionary perspectives that they are claiming things that don't happen in the world. But then saying you better not say anything that opposes this. But again, we're going to continue to do that. What we would eventually want to see is that evolution gets discarded, that gets thrown away. So that's it for today's podcast. Evolution is not just not good science, it's really not scientific at all. And the evidence that's presented for it is low confidence. So where you can have higher confidence is in the alternative. The alternative is that there is a God and he made the world and he made different kinds of life forms. And from those different kinds of life forms, he used this idea of natural selection, what we call natural selection, and he put the capability in the genomes of these different life forms to adapt to their surroundings and their environment. That is what makes the most sense from the science. The idea that there was one ancestor, that life just popped into existence from non-life, and then from that single ancestor, everything that we see has come to exist, needs to be thrown in the trash heap. It needs to be thrown in the trash can. This guy is resembling Kobe here. That's what we need to do with that. And we need to get rid of that. And if you're an atheist and you're saying, well, I still don't want to go with the creation model, okay, but you got to come up with something better than that. And I think that's what, if you're not aware, there are many atheists, former evolutionists, they don't want to go with that second hypothesis. So they are looking for a third. They're looking for something else that they can go with, because the current Darwinian evolutionary model is not science. So it's time to throw it away. That's it for today's show. Until next time, keep asking questions, keep the faith.